These are the notes for Mod J, Unit 3, Lesson 2. There's just one learning target. It's the third one here. I can explain the difference between transparent, translucent, and opaque materials and what determines the color of the objects we see. Remember that in Lesson 1, we looked at the electromagnetic spectrum, and we learned that visible light is just one part of that spectrum, one set of wavelengths. So in this lesson, we'll look at the way that light interacts and talk about what causes the things that we see. Light waves travel in straight lines that are called rays. So when you think about light coming from the sun, travels in straight lines, and those straight lines are called rays. Mirrors work because they have a smooth surface that reflects light at the same angle. So we see a reflection of the image. That's why if you hold up a paper in a mirror, it looks like the writing is backwards. Visible light is found in 7 wavelengths, ranging from red, which has the longest wavelength and the lowest energy level, through orange, yellow, green, blue, indigo, and violet, which has the shortest wavelength and the highest energy. When we take all of that light combined, all of those wavelengths of light, that's white light, which comes from the sun or the overhead lights. That is not what causes us to see something that is white. When you look at an object that's white, the reason it appears white to your eyes is because it is reflecting all of those wavelengths of light, reflecting all of the different colors. Whatever an object reflects, that's the color that we see. An object that appears black does so because it's absorbing all of the colors, all of the wavelengths of light. It's not reflecting any. That's why if you're outside in the summer on a hot day, you get really hot if you're wearing black clothes. Your clothes are absorbing all of the wavelengths of light and taking on all of that energy. Whereas if you're wearing white clothes, your clothes are reflecting all of the wavelengths of light and absorbing a lot less energy from the sun, and you feel cooler. If you see an object that's a mixture of colors, if it's not one of those 7 on the spectrum, then it's reflecting more than one color back to your eyes. Something that's blue reflects only the blue wavelength of light, and it absorbs all of the others, and that's why you see that object as blue. If it's red, it reflects only red wavelengths of light, and it absorbs all of the others. So you see it as red because that's what's reflected back to your eyes. We learned in a few lessons, actually, we've talked about the fact that electromagnetic waves all travel at the same speed, 300 million meters per second in a vacuum. But once those wavelengths of light, those rays of light, enter Earth's atmosphere and travel through the air, travel through a glass window to get to you, they slow down a little bit. So the medium, the density of the particles in it, affects the speed at which light travels. We can see light separated into the visible spectrum. We talked a little bit about that in Lesson 1. If you send a beam of light through a prism, it uses refraction. It bends the light to separate it into all of the different colors. So that's why if you have a prism maybe in your kitchen or a bathroom hanging in a window or something, sometimes you'll see little rainbows on the wall. That's also why we see rainbows in the sky after it rains. Those little rain droplets act as prisms. They bend the white light coming from the sun, refract it, and cause it to separate into the different wavelengths. And we see each wavelength separately as a rainbow. Then in Lesson 2, it also talks about different types of materials, and they're classified based on how much light they allow to pass through. A material that is opaque, like a solid wall, blocks all the light. So it's dark, you can't see anything through it. A material that is transparent, like a window, allows all light to pass through. You can see clearly what's on the other side of that object. And then it's possible to have something that's not really opaque and not really transparent. Then we say it's translucent. It allows some light to pass through, but not all. A good example would be the fogged over windows in the school bathrooms. They allow some light to pass through, but you can't clearly see everything that's on the other side. And the bathroom often seems just a little bit dimmer than being outside in the open air as a result. Those are the notes for Mod J, Unit 3, Lesson 2, Interactions of Light.